This call is now being recorded.
Okay, students. So, in early class, we had seen classification of signals, in which we had discussed energy versus power signal, periodic versus non-periodic signal, causal versus non-causal signal. What else? Deterministic versus random signal. And last, we had seen even versus odd, and this was verified that even signal is called symmetric signal, and odd signal is called antisymmetric signal. So both discrete and continuous. This is, I mean, these different types of signals are valid for both discrete and continuous as well. Coming to next topic, we are going to see transformation of independent variables. So here we are considering only one variable. We are going to study only one what we call 1D signal. So we consider only one independent variable. So we are going to transform. So what way we are going to transform, that we have to see. So here title is transformation of independent variable. Now see what kind of transformation may be independent variable. So here variable I have written because I have to consider only time. So in time we have to see what kind of possible transformation may be. See here. So first one, title of this transformation is time scaling. I am saying time scaling. So what does mean of time scaling? Soon we will understand this. See here. If suppose you have a signal, something like this, yn equal to I have suppose considering x to n, yn equal to x to n, and here means find, question is find yn equal to 2xn. Let me explain this through one example. If xn equal to, take simple example 1 2 3 4, that's it. So question is if xn is given, question is to find yn which is equal to x to n. So we have to see how this is a time scaling, basically how we are having a scaling that is in time, that we have to see. See students, so here if you see this problem, what is given basically, if we go to see solution of this, so what we given is this one, xn equal to 1 2 3 4. So if you plot it, so what will be waveform? Waveform would look like this. this is n equal to 0. So at n equal to 0, nothing here, you consider this is starting where n equal to 0. This is at n equal to 1, this is at n equal to 2, this is at n equal to 3. So this is at n equal to 0, we have amplitude for x and 1. So this is dependent variable, you consider here x, and this is independent variable n. So n equal to 0, amplitude is 1. This is amplitude 1. N equal to 1, consider n equal to 1, you consider this magnitude is 2. Consider something like this. N equal to 2, we have amplitude 3. And at n equal to 3, amplitude is 4. That's all. So to plot this, we have this waveform. But what we have to find? We have to find yn, and this yn is nothing but x of 2n. X of 2n. So how we are going to draw the waveform, or how we find yn in terms of x to n? That is a question. See here, if you see this, what is basically given? This one is basically your x0. This is given to you. 2 is basically your x1. This is given to you. 3 is your x2. And this 4 is your x3. So this is what you know. So this is given to you x0, x1, x2, x3. And then with the help of this given values, you have to find x2n. So very simple. Now see how you are going to find. So first you see what you are getting x0. So what value of n means you have to concentrate over the n only, student. Remember, means what value of n should I put so that it gives you x0. So if I put n equal to 0 here in this x2n, I will be getting x2 into 0, that is x0. So here I am getting here x2 into 0. Simply what I did, n equal to 0 I put. So this is at n equal to 0, students. So if you put n equal to 0, this gives you x0. So this is what x0 is, and x0 is what? X0 is 1. Okay. Now what? Now we have to check at what value of n should I put so that I may get x1. So n will be equal to what I may put here, that is 1 by 2. If you put n equal to 1 by 2, 1 by 2 into 2, that gives you 1. So n equal to 1 by 2, you will get 1. But this is not true, student. Why? Because n cannot be a decimal value. N cannot hold decimal value. So n equal to half, you cannot take it. That is invalid value, we can say. Invalid time you are taking. N must be integer, remember. So n equal to half, if you take, you are not getting this sample x1. So this will not come, student. N equal to half, if you put here, x1 will not come. Okay, then what we have? Then you see, if we are not getting this, now we have to see for this x2. Do we get x2? Yes, you put n equal to 1. If you put n equal to 1, you will be getting here x2. So 2 into 1, that is x2. So next, n equal to 1, you will be getting x2 into 1, and x2 into 1 is x2, and what x2 value is? 3. So this 3 value will be copied here. Okay, next. Next, we have to see 3. So n equal to, you put 3 by 2. If you put n equal to 3 by 2, 2 cancel out, then you will get x3. So again, 3 by 2 is a decimal value. So this discrete cannot hold decimal value. So 3 by 2 will not be a valid time. So this sample will not come, student. So only we have a sample 1 and 3. So if you plot it for x2n, your result will be 1 and 3. That's it. This will be your answer. Understand, Vanshika, Anuradha?
Yes, sir.
Yes, sir.
Okay. So here what is basically, this is time scaling. So when you have xn and when you go for x2n, what basically time is scaled. So what way it is scaled? Now see here. So this is yn, which is equal to x2n. So n equal to 0, amplitude is 1. N equal to 1, amplitude is 3. That's it. N equal to 1, amplitude is 3. This is what you have yn. So what you have seen here, that this signal is basically compressed by how much? By 2 minus 1th sample. Means this is reduced by, means between each 0 and 2, this will be eliminated. Means 2 minus 1th sample is removed between each successive sample, we can say. So if you consider 0 and 2, so 2 minus 1th means this amplitude will be eliminated. Between this and this, means next what you have 2 and 4. Between 2 and 4, this will be eliminated. So what you are getting simply 0 and 2. At 0 what you have 1, and this 2 is now what? That is 1. So 2 is now transformed. This time is transformed from 2 to 1, and this 0 is 0 only. So this is your transformation, students. So time is basically scaled here by 2. Means you have to divide it by 2 on both, means everywhere by 2. So 0 by 2 is 0, 1 by 2 is 0.5. This is not valid, so discard it. 2 by 2 is 1, so this is okay. 3 by 2 is, this is not valid because this is decimal value. 4 by 2, this is valid, but there is no sample here, so we don't write anything. So we see for valid time, we have only 0 and 1. So whatever we have is 0 and 1, that amplitude I have written, and this is what you have, transformation in time. So this is called time scaling, and this specifically we call this is called compression. Time basically here compressed. So this is called compression. Remember this. This is called compression. When any number is multiplied with this, that integer number multiplied with this n, that is called compression. So if any decimal value is multiplied with this, that will not be compression. Remember, integer value I am saying 1, 2, 3, 4, 5, 6, and so on and so forth. So if these numbers are multiplied with n, then only we say this is compression, students. Means time will be compressed by this factor, by whatever integer numbers are there, that will be compressed by this factor. Okay, second example, I may take, if I take in place of this decimal value, what will be my solution? Okay, now see, what will be a solution? Am I audible,
Yes, sir.
students? Okay. So next, I'm considering this will be a part of time scaling only. And now I'm considering here, in place of 2n, I'm considering n by 2. Means in n, we are multiplying with 1 by 2. So what will happen? So what this scaling is, of course, this is time scaling, but what basically this function characteristic that we have to see. So same way you have to plot it xn waveform, and once you plot it, then you have to check it for this. So I'm not going to draw for xn because I have already drawn. This is x0. This we know. This is x1. This is x2. And this is x3. Okay, now we have to find yn equal to xn by 2. So here yn equal to xn by 2. Now see, what value of n should I put so that I may get x0? So if you put n equal to 0 here, so that gives you 0 by 2. 0 by 2 is simply x0. So this is okay. N equal to 0 is a valid number. So I may consider here x n equal to 0 by 2. 0 by 2 is what? 0. So this is for n equal to 0, student. So what x0 by 2 is? X0 by 2 is x0, and this value is what? 1. X0 is 1. This is what given to us. Simply I copied here. Okay. Now let me go for x1. So what value of n should I put here so that I may get x1? So n equal to 0, fine, we are getting this. N equal to 1. N equal to 1, I will be getting 1 by 2. 1 by 2 means n equal to 1 means 1 by 2. 1 by 2 means what? 0.5. So we don't have 0.5, student. But n equal to 1 is there, student. N equal to 1 is a valid number for n because this is integer. If I put n equal to 1, this gives you x of 1 by 2, but independent variable is 1. 1 still hold integer value, but sample we don't see here. Sample x0 1 by 2 means x 0.5 we don't see. So what I will assume, x 0.5, there is nothing, means I will consider as a 0. So n equal to 1, if I put n equal to 1, this gives you 0.5, students, or let me write in this way, 1 by 2. For what value of n? N equal to 1. Okay. N equal to 2. So 2 by 2, that gives you x1. Okay, fine. N equal to 2, that gives you 2 by 2. So 2 by 2 is x1. So what x1 is? 2. So you copy this value here. So this value will be 2. This is for n equal to 2. Next, for n equal to 3, this is also true. That gives you x3 by 2. Perfect. Next, n equal to 4. So n equal to 4, you will get 4 by 2. Next, what? 5 by 2. This is also okay. N equal to 6, x6 by 2. This is also okay. So here we see, for whatever value of n we are putting, that we are putting here integer number. So these are valid number. So there is no problem that we have to consider. But if you see, if you solve it, that gives you x 0.5, and we don't see any value of x 0.5 in the given. So in the given sequence, what we have, we do not have x 0.5, so I'll consider this as a 0. 3.5 means x 1.5 is not given, so I'll consider this as a 0. 4 by 2, x2 is given, so what this value is 3. 5 by 2, 2.5 is not given, so I'll consider this as a 0. 6 by 2, that is x3. x3 is given, that is 4. So what we have a result. So result for this, I'm getting this 1, 0, 2, 0, 3, 0, 4. This is your correct answer, students. So this is what. So you see here, when we do division by decimal value, I'm very sorry, when we do multiplication with decimal value, we see that whatever the sample we have in the sequence, that will be we are getting in this form. Means between each successive sample, or we can say between each successive amplitude, we are inserting 2 minus 1th 0. 2 minus 1th 0 we are inserting between each successive amplitude. So 2 minus 1th 0 means 1 0 we are inserting between two successive amplitude. Same between 2 and 3, 1 0 inserted. Between 3 and 4, 1 0 inserted. If there is another sample between 4 and 5, so there will be 1 0 in between, right? So this way we can say this sample is, now you see here, this signal is basically what we call, this is expanding. So whatever we had now you see 1, 2, 3 means we had earlier we had 4 sample. Now we have 1, 2, 3, 4, 5, 6, 7 sample. So number of samples now has been increased from 4 to 7. So this is called expansion, rather compression. So when you multiply with 1 by 2 with this small n, that sequence will be your expansion. And this is called expander. Okay, so this process is your expansion, and this is your device which you call expander. Understand, students? Any confusion, please let me know. Anyone? Either Vanshika or Anuradha?
No, sir.
No, sir.
Okay. So this is what you have a time scaling. So either you can multiply with integer number or decimal number. Second, we are going to see time reversal. Yes. I will consider same problem. Wait a minute. Now my title is time reversal. So what is, of course, this is your second part. Second transformation, I'm considering time reversal. Okay. Second is time reversal. So time reversal means if suppose this is xn and we have to find yn equal to x minus n. This is simple example I gave you. Xn is given to you, you have to find x minus n. So what x minus n? So x minus n, basically in this we are multiplying with minus 1 with small n, right? So here this is not plus, student, this is minus. So we have to see what will be our sample for this. same waveform as well as sample we have to see. Okay, see here. So this is your xn, x0, x1, x2, x3 is known. Now coming to find the value of x minus n. So how will you find? So x minus n means what? See here. This is given to you, and from this given, you have to find this. So see, x0 is given. So what value of n should I put here? That by putting n, it gives me 0. Simply n equal to 0 you put here, that you will get x minus 0. X minus 0 is nothing but 0. Okay, so I'm putting arrow mark here. Arrow indicates n starts from 0. N equal to 0, you are getting this x0. Minus 0 means x0. Okay. Next, we have to see what value of n should I put so that I may get x1. So what value of n should I put here that gives you total value? It gives you 1. So simply you put n equal to minus 1. N equal to minus 1 into minus, that gives you plus 1. So if you put n equal to minus 1, that gives you x1. So n equal to 0 here, if you go towards this side, you have plus n equal to 1, n equal to 2, n equal to 3. And if you go towards left hand side, that gives you n negative. So n equal to minus 1 will be at this position, n equal to minus 1, and you put n equal to minus 1 in this function, that gives you x1. So this is your x1, student. Next, for this x2, you put n equal to minus 2, then it gives you x2 here. Then you put n equal to minus 3 to get x3. This will give you x3. That's it. And we don't see any sample after x3. So this is what we have a result. So what x3 is, what this value x3 is 4, x2 is 3, x1 is 2, x0 is 1. And you keep this arrow mark here, which indicates n equal to 0. So we are going towards this side, so n will be negative. If we are going towards this side, n will be positive. So if you plot the waveform for this, waveform would be like this: n equal to 0, this is 1, n equal to minus 1, this is 2, n equal to minus 2, this is 3, n equal to, yes, minus 3, this is 4. So this is what you have a graph, or we can say waveform for yn, which is equal to x of minus n. And what you see here, you see if you compare the waveform of this with this waveform, this is complete reversal of this. So whatever it is happening in positive axis of this time, means whatever we have positive time axis, that same that we see in negative axis, negative time axis here. So this is just a reversal of this. So this is what we have reversal in time. So this is called time reversal, means about this imaginary axis, this whole sample is copied into other side. So this is called time reversal. So whenever you have yn equal to x minus n, this is called time reversal. So this is what you have transformation of independent variable, that is time reversal. Any confusion, students?
No, sir.
Okay. Next, third, we are going to see time shifting, and this I am leaving for you, and here only you have to complete, students. Same example I will keep, and you have to answer me. If really you understand first and second, you must answer this. If not, I will answer, no problem, but you must try here only. Consider same problem, and now I am considering my case third, which is called time shifting. So this is third transformation, time shifting. Okay, I'm considering this case x of n minus 1. This is given to you. You have to find yn equal to xn minus 1. Could you please answer me for this? What solution will be? Please do, all of you. I'm giving you 2 minutes time. What answer may come from your side? डन स्टूडेंट्स, हो गया?
Yes.
यस, ओके, बताइए फिर आंसर क्या है?
Sir, if we will keep n is equal to 1, then 1 minus 1 it will be 0. So it will be x0.
Okay,
And
so at n equal to 0, what is value?
sir, 1.
Okay, you tell me at n equal to 1. At n equal to 1, what value is?
Sir, at n equal to 1 is
ओके, नो प्रॉब्लम। मैच करा लेना आप लोग, जो भी आपने किया है वो सही है या नहीं। यू सी हियर, no problem. See here students, how do you proceed? Same concept. First you see what is given to you. So this is given to me, x0 to x3. That's it. With the help of this only we have to find this. See here. So first what we have x0. So how would I get x0 from here? Xn minus 1. That is a question. So what value of n should I put so that it gives me x0? Simply you put n equal to 1. If you put n equal to 1 here, if you put n equal to 1 here, so 1 minus 1 that gives you x0, and x0 is what? 1. So what I'll say here, simply I write n equal to 1. At n equal to 1, this xn minus 1 that gives me 1 minus 1, this is what? This is x0, and x0 is what? 1. Okay. Next what? I have to read this x1. So what value of n should I put that gives me x1? So n equal to 2. So 2 minus 1 is what? X1. So this will give you, for n equal to 2, this gives you x2 minus 1. And x2 minus 1 is what? X1. X1 is 2. Next, for n equal to 3, n equal to 3 is it gives you x3 minus 1, that is x2. So this is x3 minus 1. This is x2. X2 is 3. Next, n equal to 4. N equal to 4, that gives you 4 minus 1. X4 minus 1 is x3, and this is your 4. That's all, student. Now we don't have any sample in the given sequence. So we have to stop here. And now question may ask, what is the value at n equal to 0? So if you see n equal to 0, if you put 0 minus 1 is what? X minus 1. X minus 1, we don't have any sample. So x minus 1, if we don't have any sample, so what I will consider this as a 0. So here my observation is, this is 0, 1, 2, 3, 4. This is my arrow mark. This is n equal to 0. So what is the waveform? So waveform will be like this. This is 1. This is 2. This is 3. This is 4. So 0, 1. I'm very sorry. Wait a minute. This is 1. This is 2. This is 3. This is 4. This is n. And at 0, what you have? Magnitude 0. So what is your observation? You see, earlier, if you plot it, this 1, 2, 3, 4, it started from this 0, right? If you plot the waveform for this, what was there? See, this is 1, 2, 3, 4. This is 0, 1, 2, 3. This is your n. This is xn. And this is what? Xn minus 1. Now here, if you compare both, so this waveform basically originate from n equal to 0, simply when you had xn. Now, when you have xn minus 1, now this complete waveform is shifted by 1 second towards right. So whatever it originates from 0, now it originates from 1. So what I mean means this sample is shifted from here to here. This is shifted from here to here. This is shifted from here to here. And this 3 is shifted from 3 to 4. So this is called time shifting. So what time shifting is? So whatever the sequence xn, when it is xn minus 1, so whole xn graph will be shifted by 1 second towards right, student. Towards right. In the same way, if I write xn plus 1, you do this from your side. So what way I will write this? Xn minus 1. So what I will say, this xn means this xn will be shifted by minus 1, means minus 1 means this xn will be shifted not to right, this side, to left hand side. So if it is plus 1, that will be left hand side. By 1 second, it will shift towards left. If it is n minus 1, that will be shifted towards right by 1 second. So this is called your time shifting. Time shifting by, 1 second towards right. If it is minus 1, if it is plus 1, it is shifted by minus 1 second towards right. So that is your conclusion. Understand? Vanshika?
Yes, sir. Yes, understood.
Perfect. So these three transformations are very, very important. And with the help of this, you can draw any kind of graph, whether it is related to continuous time or it is related to discrete. So please remember these three concepts. Next, we have one more transformation that is not in independent variable. That is in basically you can say dependent variable, means when you have this kind of and you know this is very, very simple. This is not independent variable. This is related to dependent variable. So same you consider this problem. So basically here title I may consider that amplitude scaling. Basically this is amplitude scaling. And again, this is I'm saying this is not a part of your independent variable. This is based on dependent variable, but you should know how basically we have to do scaling in amplitude. So same problem you consider, and if suppose I give you problem like this, yn equal to suppose twice xn, and xn is this 1 2 3 4. So what will be the amplitude for this yn? So if it is twice xn means 2 you have to multiply on both sides. So this will give you 1 into 2, this will give you 2 into 2, this will give you 3 into 2, this will give you 4 into 2. So this will be 2, this will be 4, this will be 6, this will be 8. So I hope you know this. Yes or no, students? So this is basically comes under amplitude scaling. If it is multiplied with a integer number, amplitude is scaled up. If it is multiplied with decimal value, amplitude will be scaled down. That's it. So this is all about your transformation of independent variable or dependent variable. So next class we will see, students, based on this we have to see if functions are given to us, how to plot the waveform, and vice versa. Means if waveforms are given to us, how to get the function. So many times in gate examination questions come from this side, from function to waveform and waveform to function. We have to understand very nicely. Also we will understand first concept, and then we have to see shortcut. In gate question, if question comes, how fast I may answer, that also you should know, right? So in both ways I will give you a solution, and you will ask whenever you have doubt, right? So that's all for today from my side. Rest I'll see in next class. Okay, Vanshika, Anuradha.
Okay, sir.
Okay, thank you.
Thank you, sir.